Good day everyone. We will report titled A Final Business Analytics Case Problem. Objectives: provide a capstone business analytics business analyst overview with a case study problem. Second, show stepwise connection of the descriptive, predictive, and prescriptive step in the business analyst process. So for the introduction, in this chapter, a closing illustration of how business analyst process can be applied by presenting a final case study. This case study is meant as a capstone learning experience on a business analytics process discussed. Throughout the book, several of the concept and methodology presented in prior chapters and appendices will once again be applied here. So, sinasabi lang dito sa slide na to is, dito ginagawa yung final step ng case study about business analytics. The main purpose of this is to help financial of an organization with business analytics. In this chapter, we seek a closing illustration kung paano ang BA process ay na i-apply gamit ang huling step, which is the presenting a final case study.
A Midwest U.S. commercial manufacturing firm is facing a supply chain problem. The manufacturer produces and sells a single product, a general purpose small motor, as a component part to different customers who incorporate the motor into their various finished products. The manufacturer hires a supply chain network that connects production centers located in St. Louis, Missouri, and Dallas, Texas, with 6 warehouse facilities and serve commercial customers located in Kansas City, Missouri, Chicago, Illinois, Houston, Texas, Oklahoma City, Oklahoma, Omaha, Nebraska, and Little Rock, Arkansas. Part of the supply chain problem is the need to keep the cost of shipping motors to the customers as low as possible. The manufacturer adopted a lean management philosophy that seeks to match what is produced with what is demanded at each warehouse. The problem with the implementing this philosophy is complicated by the inability to forecast the customer's demand month to month. If the forecast of the customer's demand is too low and not enough inventory is available, and under age of inventory, the manufacturer has to rush order motors that end up being costly to the manufacturer. If the forecast is too high and the manufacturer produces and ships unwanted inventory and overage of inventory, the warehouse is incurs wasteful storage costs. The management of the manufacturing firm has decided that an analytics-based procedure needs to be developed to improve overall business performance. Analysts could use this procedure each month to develop an optimal supply chain schedule of shipments from the 2 supply centers to the 6 warehouse demand destinations that would minimize costs. A key part of this procedure would be to include a means to accurately forecast customers' demand and an optimization process for shipping products from the manufacturing centers to the warehouse demand destination. This problem sa supply chain ay kailangan natin ay panatilihing mababa ang halaga ng mga motor sa pagpapadala sa mga customer natin hanggat maaari, dahil upang ang mga tagagawa ay nagpatibay kung ano ang ginagawa nito sa kung ano ang gusto ng bawat customer. Ang problema naman natin sa pagpapatupad ng mga philosophy ay komplikado sa atin dahil wala tayong kakayahang hulaan ang demand buwan-buwan. Lalo na kung ang pagtataya ay masyadong mataas at ang tagagawa ay nagpapadala ng hindi sakto sa inventaryo, ang bodega ay nagkakaroon ng maaksayang gastos sa pag-imbak.
Descriptive analytics analysis. Determining a procedure by which analysis teams can determine optimal shipments between supply resource, demand destination requires differing types of data. Data requires to plan shipments. The total manufactured supply of motors produced at the St. Louis and Dallas plant is determined once the forecast demand is established. The BA team established that there is an ample capacity between both plants to satisfy the forecasted customer demand at the 6 warehouse demand destinations. The BA team determined that the cost data for shipping a motor from a production center to the customer depends largely on distance between the cities where the items are tracked directly by the manufacturer to the warehouse. Based a table, for example, it costs the manufacturer $4 per motor to ship from St. Louis to Kansas City. These cost values are routinely computed by the manufacturer's cost accounting department and are assumed by the BA team to be accurate. The present system of forecasting customer demand usually results in costly averages and underages shipped to the warehouse. In the past, the manufacturer will take a tree-value suiting average to estimate the monthly demand. The resulting time series data collected on warehouse customer monthly demand files is represented in the table. The table is an example of actual monthly customer demand in motors. It was decided that the most recent 3 months, bold months of 25, 26, and 27, would not be included in the model development, but instead would be used for validation purposes to confirm the forecasting accuracy of the resulting models. This is similar to what was referred to as a training dataset on a validation dataset.
As a part of descriptive analysis, summary statistics were generated from SAS Table 8.3. The mean values provide some basis for a monthly demand rate, but at this point, consideration of overall behavior within data distributions is required to more accurately capture relevant variation. Makikita natin dito yung data ng Kansas City at ng Oklahoma City in customer demand in motors. At saka dito, makikita natin yung summary statistics na were generated using SAS as a part of the descriptive analysis. The mean values give some foundation for a monthly demand rate, but at this point, analysis of overall behavior within data distribution is required to reflect meaningful variance more precisely. Other statistics to that aim can provide a picture of the data's distribution. Dito nga natin makikita yung sa next slide. Ito, makikita natin sa figure 8.1 at saka figure 8.3. Diyan yung graph ng Kansas City, yung left side. And then yung right side, dito naman nakikita natin yung sa ng Oklahoma City. Yun yung 8.2 at saka 8.4. Makikita natin dyan na yung figure 8.1 to 8.6 is the analysis uses SAS to build the line graphs of the 6 client demand files to better portray the basic structure of the data and comprehend its pattern. According to the summary, data and now to the graphs ay ang ilan sa mga foundation ng demand ng consumer ay lumilitaw na medyo linear, ang ilan naman ay malinaw na hindi linear, at ang ilan naman ay napakaraming pagkakaiba-iba na mga ito ay hindi maintindihan, kagaya nung sa may graph ng 8.1 na Kansas City. 'Di ba, hindi naman natin maintindihan kung ano yung pagkaka-linear ng graph niya. At ang pagtuklas ng halos perfectong linear ay napag-uugali ng demand ng customer sa Chicago 8.2. Yun nga yun, yung graph na to na 8.2 ay makikita natin dyan na maayos naman yung kanilang data. Kasi makikita natin 0 hanggang mapapunta sila sa mataas na rate. And ito nga yung sa table 8.4 na Oklahoma City, yung graph niya ay
naghihikayat sa paggamit ng isang simpleng linear regression ng modelo para sa mga layunin ng pagtataya. Ang nagpapalinaw ng hugis ng linya niya ay yung parang kampanang non-linear, ganon siya. And then, na function para sa Austin, ito po yung 8.3 na table na graph. At Little Rock naman ay ang isang paghihiwatig na ang isang non-linear regression ng modelo ay angkop. Dito yung figure 8.6, which is as an extension. Dito naman sa figure 8.5 at saka figure 8.6, to better depict the general shape of the data and to understand its behavior, the analysis create line graphs of the 6 customer demand files using SAS in figure 8.1 to 8.6 as expected based on the summary statistics. And now visually from the graphs, some of the customer demand functions look fairly linear, others are clearly nonlinear, and some passes to much variation. There are unrecognizable, identifying the almost perfect linear customer demand behavior in the warehouse in Chicago. Yun nga yung sabi ko kanina na hindi nga natin yung linear at non-linear na curve ng kanilang graph. And in summary, the fact that 2 of the 4 warehouse series data files have higher time series variation than the other 4 warehouse files does not impede a reasonably good forecast in these situations, because 4 of the 6 client demand warehouses appear to follow a pretty predictable pattern of activity. They will assist increase overall accuracy even if the significant fluctuations of the other 2 warehouses add some forecast error. Thank you.
Predictive analytics analysis. In this section, we continue with our illustrative example. Here we use the descriptive analysis step that requires model development efforts and then models validation. For example, to complete the predictive analysis, we determine forecast for warehouse and demand. Developing the forecast model. The descriptive analytics analysis has suggested a course of action in identifying appropriate forecast model in this next step of BA process to ensure that the best possible forecast model and confirm the descriptive analytics analysis result. The analyst will utilize curve fitting with SAS each of 6 customer demand data files in analyzing through the SAS program to generate potential regression model.
Summary of BA procedure for the manufacturer. The intent of this BA application is to develop a BA procedure for the manufacturer to utilize every month in planning the supply chain problem of setting the supply chain network. This BA procedure based on the BA team analysis presented here involves both data collection effort, statistical analysis, and the application of optimization software, specifically 1. Collect shipping cost information from the firm cost accounting department. 2. Collect and update monthly actual demand values from warehouse customer. 3. Collect supply center supply capacity to ensure sufficient supply capacity exists to handle monthly demand. So, kolektahin ng supply center ng kapasidad ng supply para matiyak na may sapat na capacity ng supply para ma-handle ang monthly demand. 4. Rerun curve fitting software and new and old actual demand data to determine the best forecasting model based on the R-square and other statistic as needed. So, dito sa 4, para matukoy ang pinakamahusay na model is batay sa square at iba pang statistical kung kinakailangan. 5. Forecast warehouse customer demand and affirm through analysis that the resulting estimates are truly based on the best forecasting models. Revise as needed to select the best model. 6. Incorporate the cost, supply, and forecast demand information into a linear programming model, similar to what was developed. Run the IP or LP model and extract the shipping schedule from the model output. So, 7. Patakbuhin ng IP o LP na modelo at i-extract ang schedule ng pagpapadala mula sa output ng modelo. A BA is not complete without showing that business performance can or will be improved. This case study has a basis for comparison. In comparing the MAD statistic from the present forecasting procedure and the BA proposed procedure, we can observe a potential for improvement in shipping.
The MAD statistic represents the average monthly overage or underage of motors that could have been avoided if the BA proposed procedure would have been in place. Such needless shipment wastes effort and add to consistent inefficiency for the manufacturer.
As can be seen in Table 8.18, the current procedure of using a smoothed averaging to generate a forecast result in fairly large math statistic compared to the proposed BA procedure. The total of MADs in Table 8.18 clearly show a significant reduction in monthly overage or underage when using the proposed BA procedure in forecasting motor customer demand. Reducing the accuracy in forecasting also translates into minimizing wasted cost of shipping the motors that are either not needed in the warehouse during the low customer demand period or rush order when shortages occur. So this result revealed that the implementation of the proposed BA procedure for the supply chain shipping schedule problem could help improve business performance for the manufacturer over what was previously used to forecast the last 3 months.